Hello everyone, this morning I'm coming to you from my home and we are going to be looking at pedigrees for our notes for today. So when it comes to pedigrees, these are visual representations of several generations in a family tree. So you've probably heard of family trees, or you've probably heard of 23andMe and Ancestry and all that. So that's what a pedigree is, okay? So we're looking at visual representation of different generations in a family tree, okay? And there are a few things that you have to be able to do when it comes to a pedigree. So what should you be able to do? One, you have to be able to determine the mode of inheritance. So that's just a fancy way of saying, how is this trait inherited? Is it dominant recessive? Is it incomplete dominance, codominance, multiple alleles, X-linked? Okay, so that's what it means for mode of inheritance. And then the second thing that you have to be able to do is you have to be able to determine the genotypes and phenotypes of the individuals. So when I'm looking at this family tree and when I'm looking at this pedigree, can I figure out what the genotype of the grandparents is, or the grandchildren, or great aunt, or so on and so forth? Okay, so the very first thing that we're going to look at is in your data booklet, you would have your symbols. And so these are the symbols for pedigrees. I'm going to try to straighten this out. There we go. Okay. And so just some information here when it comes to these pedigrees. So as you can see, a square represents a male, round is a female, and then one line between them is the mating. If you have two lines, that's mating between close relatives. And then what you have is the vertical lines. The vertical lines are the offspring. So these two mated with one another and had a son, then they had a daughter, and then they had another son. So as you can see here, the Roman numerals represent the generations, and the Arabic numbers, those are the individuals, and they're placed in birth order. So as I said, this woman and this man had a son first, then a daughter, then another son. And then there's some sort of weird things that might kind of come up on pedigrees, like for example, identical twins. Here, as you can see, this is identical twins. This is fraternal twins or not identical twins. But really what we need to focus on, these are not going to show up very often. What we need to focus on is the fact that when an individual is shaded in, that's affected by whatever condition that might be. And it doesn't have to be a disorder. Curly hair is dominant over straight hair. And so if you're shaded in, then that means you have curly hair, okay? Whereas if you're not shaded in, then you're unaffected. So in that case, you would have straight hair, okay? So those are the symbols that we need to have for the pedigrees. And so in order for us to be able to determine the mode of inheritance, there are little tricks that we can look at when we examine a pedigree. So first of all, we need to make the distinction between, is the trait that I'm looking at autosomal? Okay, so remember that an autosomal condition is found on chromosomes 1 to 22. Okay, so whatever that gene that causes the condition or the disease has to be found on chromosome 1 to 22, and that's why it's autosomal. Okay, whereas sex-linked, in this case, we're looking at on the X chromosome. So that gene is going to be found on the X chromosome. And if it said holandric, holandric could be on the Y chromosome. But again, those are not conditions that show up often. So we're not going to worry about, we're just going to worry about autosomal 1 to 22. It doesn't matter the gender, or sex linked, where the gender is going to have an effect. It's going to play a role. And we're going to see that in just a second. So we're going to start with autosomal. And we're going to see the difference here. We're going to do autosomal dominant versus autosomal recessive. So remember that autosomal dominant means I have a capital A. Doesn't matter what the other one, because as long as I have a capital A, I will have that condition. Whereas recessive, in order for me to have the condition, I have to have 2 little a's. Okay, so that's what that means when we're looking at autosomal. And so for autosomal dominant, then what do I want to do is I want to look at my pedigree. And in my pedigree, every generation will have affected individuals. So when I'm looking at the pedigree itself, if I see that I have a shaded in individual in every single one of my generation, that's a good indication that I'm dealing with a dominant condition. Okay. And then another thing that I want to look at, because it's not always the case, but I want to look at another thing. An affected child will have always at least one affected parent. We know that we get our alleles from our parents, right? That's what Mendel taught us. And so an affected child that has the condition, that has inherited that dominant allele, must have gotten it from one of the parents. So at least one of the parents has to have that affected allele, that gene that has been affected. Okay, so I'll show you an example here. I think it's this one. I want to show you. I'm going to put it down here so that, okay. Oh, I made a copy of it. I didn't even know I could do that. Okay, so let's say that this is the pedigree that I have. And so let's start marking this pedigree up with some of the things that we do know. So then this is the first generation. This is our second generation. This is our third generation. And we have, we can blow this up a little bit. Make this a little bit smaller. So this is individual 1 and 2 for that generation. This is individual 1, 2, 3, 4, 5. We number all of our individuals that way. And then generation 3, I have 1, 2, 3. Okay. So if I were to ask you about the genotype of a particular individual, I would say, what is the genotype of individual 2, 3? So if I was looking for 2, 3, then 2, 3, this is who I'm looking for. Okay, so that's why we number the individuals that way in our pedigree. Okay, so now I'm going to shade some of these guys in just so that we can look at, so this individual is shaded in, and then I'm going to have, she's going to be shaded in, and he's also going to be shaded in, and this one. Okay. So I'm going to be looking at this pedigree, and I'm going to say, okay, all of a sudden I see that every generation is affected. So this generation has an affected individual, this generation does, and this generation does. Okay. So now the next thing that I have to look at is an affected child will have at least one affected parent. So here's my affected child, there's my affected parent, here's my affected child, there's my affected parent. Okay, so far we're following the rules. Now, how do I find the genotypes for these individuals? Okay, we said that if we're looking for dominant, this is, when a person is affected, this is what it would look like. So when it comes to these individuals, what I do know, and I'm going to write these in blue, this individual has a big A. I don't know what the other one is, so I'm just going to leave it blank for now. Now this individual right here is not affected. Therefore, they must have 2 little a's. In fact, all of the ones that are not affected will have 2 little a's. So those ones are the easy ones for me to fill out. Okay. Now this individual right here, I know it has one. I don't know what the other one. I know this one has one, and I know this one has one. I don't know what the other one is. So I'm just going to leave them blank for now. To figure out what the other allele is, the missing the blank, I have to look at the parents. So when I'm looking at this child right here, I know that they got the big A from this parent, and the other allele comes from mom. So mom, the only thing she can give that child is a little A. Therefore, this individual has a little A. The same goes for their first daughter, their first child. Got the big A from dad. The only thing mom can give her is a little A. So I'm going to put a little A in there. Okay. These ones are all filled out. So I'm okay with these guys. Now this is the other individual that I'm missing. And again, when I look at mom, I see that she has a little A, and therefore that daughter got the little A from mom. So there is the genotypes. Now what about this individual right here? Okay. What can I tell about that individual right there? Well, for that, I'm going to be looking at this son. This son right here got a little A from mom. That's easy. The other little A must have come from dad. So now I know that dad is also heterozygous for that trait. Okay. So that's the pedigree for dominant recessive. Now let's have a look at, for dominant, not for recessive. Let's have a look at recessive. Now for recessive, what I'm going to see here is that the trait is going to skip generations. So in this one, when the dominant one, we had every generation had an affected individual, whereas in this case, we're going to see that it skips generations. And another thing that I'm going to look at is the fact that unaffected parents may have affected children. Children. So the opposite of what we had with the dominant, if I have an affected kid, I must have an affected parent. Here what we have is we have 2 parents that are not affected by the condition, but they can have a child who's affected. If both parents are heterozygous and they're carrying the little A allele, they could pass that on to their children, and their children could be affected. Okay, so same idea here. We're going to look at the same pedigree for these guys. So I'm going to give you the same exact scenario. Okay, trying to line it up just like that. And again, we have generation 1, 2, and 3. Individual 1, 2, 3, whoops. 1, 2, 3, 4, 5. 1, 2, and 3. Okay, now I'm going to give you the affected individual. So in this case, this individual is going to be affected. And then the 2 girls are going to be affected. And the little boy over here is going to be affected. Okay, so when I'm looking at this pedigree, I see that this generation is affected and this generation is affected, but this one is not. Okay, so right away I see that it skips a generation. And then I have affected children, parents don't have it. Affected children, parents don't have it. So I can see that it is a recessive trait. So now what about filling in our genotypes? Okay, so again, we're going to make this bigger. Now this time, in this case right here, when I had a shaded in tile, that's when I would put a capital letter, whereas the ones that were not shaded in would get the 2 recessives. Okay, now in this case right here, I just deleted the little boy. In this case right here, what we have is every time excuse me, every time that I have a shaded in tile, that's when I would put the 2 little A's. So these guys are affected. These guys are affected. And they are affected. Whereas the rest of them don't have it. And so I'm going to put just A blank, and A blank. Okay? So now let's look again at how we fill out these genotypes. So this child has 2 little A's. One must have come from mom. One must have come from dad. So there we go. Okay. This individual right here, let's look at their children. Again, one came from dad. The other one must have come from mom. So I'm going to put it there. And the same goes with this one. One came from mom, one came from dad. So both of the parents here are going to be heterozygous. Now the only one, and sometimes the question on the diploma would be which individual's genotype you can't be certain of. The only one I can't be certain of is this daughter. She did not mate with anybody, did not have any children. She could have gotten big A from mom, and she could have gotten another big A from dad. She could have gotten the little A, so we don't know for sure. So that one is going to be left as a blank. Okay, so that's the situation for autosomal dominant and recessive. Now, we also saw other forms of inheritance when it came to autosomal. We also saw incomplete dominance and codominance. So in this case, what I'm going to be looking for incomplete dominance and codominance, I'm going to be looking for a third phenotype. So the same way that we were looking at flowers and we had a red flower and a white flower and then we ended up with the pink. So there's a third phenotype that shows up. And if that third phenotype is a mix, I know it's incomplete. Whereas if that third phenotype is both of the first 2 showing up together, then I know it's codominance. Okay. And then the other type of inheritance that we saw was multiple alleles. So obviously here we're going to be looking for more than 2 alleles, right? So we're going to have multiple. And so we're going to be looking for a hierarchy of dominance. So they're going to give us some sort of a hierarchy of dominance. This is dominant over that, over that, over that. And a great example of this would be blood groups, right? So blood groups, you have A, B, and O, right? So we see that we have different blood types that we can have, different multiple alleles. You have the A allele, the B allele, the O allele, and it gives you a hierarchy of dominance there, right? So that would be for autosomal. So now the ones that we need to look at next is sex-linked. Because for sex-linked conditions, remember these are just on the X chromosome. Again, what we can have is we can have dominant sex-linked. Okay, and so in this case, what I need is I need an X, let's say with a big A. The other one doesn't matter. Whereas if I have a recessive, I have an X with a little a, and that's is going to be how my individual is affected. So here, for dominant, I only need one affected X to have the condition. Whereas in this side, I need both X's to be affected in females, obviously. Oops. So this is for females. So both X's to be affected to have the condition. So again, this is for girls. Okay, so we're gonna have it like that. So then, the same way that we had some techniques or some sort of tricks for us to remember for the pedigrees to see if it's X-linked or not, we can also look at different individuals. So when it comes to X-linked dominant, what I want to do is I want to look for an affected father. So look at your pedigree, and you're going to find a father that is shaded in, a boy that is shaded in, the square that is shaded in, okay? And all of his daughters will be affected. Okay, so all of the daughters of an affected father will have the condition. Whereas when it comes to X-linked recessive, we're going to look for an affected mother. All of her sons will be affected. Okay, so when it comes to dominant, the father is giving it to all the daughters. And then when it comes to recessive, the mother is giving it to all the sons. All right. So again, for that, we're going to look at some pedigrees. So I changed these up just to give you a different view so that you're not always looking at the same pedigree. Okay. So again, we're going to one, 2, and 3, and 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4. And let's shade some individuals in, so we'll give you some idea. So we're going to make mom affected. We're going to make here this individual, and then these girls are going to be affected here. Okay, so that's what we have there. So I'm going to be looking at an affected father. All of the daughters have it. Okay. So how do I fill this out for my genotypes? Okay. So here, this, remember, it is X-linked dominant. So mom has it. So let's say big A. And she has an X. I don't know what the other one is because you only need one big A to have the condition. But dad doesn't have it. So if dad doesn't have it, I'm actually going to write this on the outside for these ones. If dad doesn't have it, then he must have the little a and a y. Okay, so again, I can start to fill some of these out. So this individual has it, so he must have a big A, and he's a boy. She doesn't have it, so X, little a, X, little a. He doesn't have it, X, little a, y. And now these girls have it. So and I'm just going to leave it blank. Okay, so now I'm going to have to figure out what I'm missing. So here, when I'm starting with mom at the very top, she doesn't have one here. Now we know when it comes to this boy got the Y from dad. The X with the little a must have come from mom. So she has a little a. Okay, now I'm going to look at these girls. On this side, I'm going to look at 3, 1, and 3, 2. So 3, 1, and 3, 2, they got the big A from dad. What's the only thing mom can give them? The only thing mom can give them is a little a. So for both of these daughters, they are heterozygous. And all the other ones are filled out. So I don't have to worry about any of the other genotypes for this particular pedigree. Okay, so let's do the same thing now for recessive. Okay, so I'm going to fill out 1, 2, and 3. 1, 2. All right, let's shade some individuals in. Let's see, this time I want mom to be affected. I'm going to have this individual and their son. here. And this daughter. Okay, so these are the affected individuals. Okay, and so it's time now to fill out our genotypes. So now remember that we're dealing with a recessive condition. Therefore, if I have a woman, a female that is affected, she needs to have 2 little a's. So when I look at this pedigree right here, she has 2 little a's. The man who's affected, he has a little a and a y. Little a and a y. Little a and a y. She's affected, so she needs to have both 2 little a's. Okay. The rest of these individuals are not affected. So this father has got a big A-Y. Big A-Y. Now here, not affected. I'm going to leave the other one blank. Not affected. I'm going to leave the other one blank. Same here. And blank. So now we have to fill out the blanks that we have. Okay, so this mother, she has only 2 little a's to give. So her daughter, which is individual 2-2, got X big A from dad. The only thing mom can give her is the X little a. So with pedigrees, as you can see, the rule is always 1 comes from mom, 1 comes from dad. Okay, so then here again, mom, the only thing she can give her daughter is the X little, oh, sorry, it's not her daughter. She's married, okay? So then we have figured it out. We can figure out this side, and we'll get to that one in just a second. So this side right here, again, I have a daughter right here. I don't know what the other one is. So this daughter got a big A from mom. What's the only thing dad can give her is a little a. So we have a little a right there. Okay, now we get to this side. So we have this child right here, and the only thing dad can give her is a little a, so we're gonna do that. And then we have to figure out mom. Okay, now mom is the only one that really we can't know, because again, she gave this big A to her son and she gave this big A to her daughter. Okay, do I know what the other one is? No. If they had a child that was affected, if they had a child that was shaded in, like a daughter that was shaded in, then I would say, okay, she got that from mom and from dad, and that's how we have 2 little a's. But for that, we don't know. So the only individual that we can't know for sure in this pedigree is that individual over there. Okay, so that's what you need to do for pedigrees, just by looking at them. You know, is every generation affected? Is it skipping a generation? That'll give you an idea if it's a dominant or recessive autosomal. And then when it comes to X-linked, the first thing I'm going to do is I'm going to check out and see if I have an affected father and all of the daughters are affected. That might be an X-linked dominant. I'm going to check out if I have an affected mother. If it seems to be mostly boys, then I could probably think that it's an X-linked recessive. Okay. And so I'm going to give you a worksheet for this. I'm going to get you guys to practice a little bit. And what you're going to have to do for your assignment coming up is you're going to have to create your own pedigree. So you're going to have to generate something that looks like this. And you're going to have to say, okay, here is grandpa and grandma. Here's mom and dad and my uncle and auntie and uncle. And then here's all the kids. And oh, look at that. There's me. Okay, and you're going to choose a condition. It could be anything from, like I said, dimples. This, having a cleft chin, is also a condition. Having a widow's peak is a condition. Having mine, I have attached earlobes. Okay, so the earlobes right here are attached. There is no, sort of sometimes it comes as a dip like this, and then you get the face. So having attached or detached lobes. You can choose any of those human conditions. You can search them up on Google and find out if they're dominant or recessive, and you're going to generate a pedigree and give the genotypes of the family members in your family, or you can choose a famous family. So I will be putting up that assignment tomorrow. But for now, I'm going to leave you with these notes. And if you have any questions, make sure that you come to tomorrow's meet with those questions and we can discuss them then.